Hello and welcome back. We have now covered all of the theory we need for our reset desired distance method. Now we're ready to go ahead and code that in. We're back in Visual Studio 2010. We're inside our TP camera class. So Lee, what is it we're going to be doing first?
Well, just like all our previous videos, we're going to set up some fields that we're going to need inside of this method and throughout the rest of this class to make all of this resuming the desired distance work correctly.
Right, there are several different things we're going to have to add in various locations.
Right, we're going to need a public float distance resume smooth. Now this is going to be the smoothing factor that we're going to use when we're moving our camera back to the position that we would like it to be. I'm going to default this to 1F.
And get rid of the rogue Q in it?
Yeah.
You gotta watch those rogue Qs, man. They just kind of pop in out of the clear blue.
Along with the R's, D's, G's, A's.
Yeah. Several other letters of the alphabet.
Yeah, pretty much everything that's on this keyboard.
Gotcha.
So, all right, let's set up a couple of private fields real quick. One of them going to be the distance smooth. This one is with a small d, though. This is the private one, which I'm going to alternate between assigned to our distance smooth and our distance resume smooth.
Okay.
So I'll just set this to 0 to zero it out. The other float that we're going to need is our pre-occluded distance. This is what's going to hold the distance value every time we move the mouse wheel. So we're going to calculate desired distance. We're going to set pre-occluded distance to equal that desired distance. And it's going to stay there until the player moves the mouse wheel.
Okay. I think we were calling that pre-occlusion distance before, but I don't really care. If you like occluded better, we'll go with that.
Well, in the code that we've got is occlusion. In the theory, you started calling it occluded.
Did I?
I liked that better.
Man,
so,
I can't remember.
So I'm going to keep what we had in our theory video.
Whatever makes you happy, man.
So now what we need to do is some initial setup. We normally start our setup with start, and inside of start we call reset. So I'm going to go to reset, and inside of here we're setting desired distance to equal distance. I also want to set our pre-occluded distance to equal distance as well. This is going to get everything in a known state whenever we start the game or anytime we reset the camera. Okay. I just want to get that out of the way to start with. Now inside of handle player input, every time we move the mouse wheel, we now have a couple of additional things that we need to do. One is setting our pre-occluded distance to equal desired distance. So that will match those two of them, or match the two distances together. We also want to go ahead and set our distance smooth lowercase equal to distance smooth. This means at this point in time, we know where we are. We want to be using the normal distance smooth. We're not going to be trying to be putting the camera back to the pre-occluded distance. Now, the other part inside of calculate desired position, instead of using the distance smooth with the large D, we want to use the private variable, not the public.
Okay.
So we're going to switch that over to use the lowercase. Inside of check occluded, every time we move the camera, we're going to force desired distance to equal distance to get rid of smoothing. This is the point in which we know that we're no longer at our pre-occluded distance, so when our camera is no longer occluded, we want to use the resume smooth, the distance resume smooth.
Right.
So we're going to set lowercase distance smooth to equal our distance resume smooth. This will give us the smoothing as the camera comes back out. That should be all the little changes that we need to make throughout the code, with the exception of one. And I'm going to skeleton in our reset desired distance method first. So we're going to do void reset desired distance. It's not going to take anything in. It's going to return a void, or not return anything, so its return type will be void. But before I do anything in here, I want to take this and I want to make sure it gets called. And we're going to call it inside of calculate desired position before we evaluate the distance.
Okay.
So we'll go through and we'll call this. This will reset our distance if we need to. And then we'll go through the whole process of recalculating our new distance. So that will be all the stuff that we need to do throughout everything else.
Right.
What we still need to do is put the functionality into reset desired distance. Now, as we mentioned in the theory, what we have to do is do a check to see if desired distance is less than our pre-occluded distance.
Which is another way of saying, is our desired distance closer than our pre-occluded distance?
If this is the case, then we know our camera has been repositioned to something other than what the player had originally intended with the positioning of the mouse wheel.
Right. Well, we know that some sort of occlusion correction has taken place.
And we want to do tests to see if our position that is at the desired or the pre-occluded distance is now available. If it is, we're going to tell the camera to start moving back there. So we're going to set up a var and call it POS for position, which is going to hold the results of calculating a new position. We have a method that we created called calculate position, not the calculate desired position, but the calculate position.
That's right. Calculate desired position actually calls on calculate position.
Right. And if you remember way back when we first set this up, we had split it out saying that there was a reason for doing this. This was the reason we did it, because we're not, in this case, we don't want to calculate desired position, and we don't want to do any distance smoothing or reevaluating the distance. We just want to get a position relative to our rotation X, rotation Y, and the distance we send it.
Right.
Now, our mouse Y and mouse X are still relevant in this case. We're going to swap them out and replace mouse Y for rotation X and mouse X for rotation Y for the same reasons we did it before. But the distance, instead of using desired distance here, we're going to use our pre-occluded distance. This is going to calculate a new position for us out in space at the distance that we have saved inside a pre-occluded distance based on our rotations about X and Y.
Right.
So once we have that new distance calculated, we're going to do a check camera points call. This is basically going to tell this method that, hey, we've got this new point. Go create a near clip plane object for that and set up the points and test all those points and see if those aren't going to be occluded. Because if they're not occluded, that means it's okay to move our camera back. So we need to do that. So we'll set up a var. We'll call it nearest distance. And there's that Q again.
There's that rogue Q sneaking back in. You got to watch out for it, man.
Yep. So we're going to do a check camera points, and we need to send it a from point and a to point. Our from point is still going to be target look at dot position. But instead of sending it our camera's position or our desired position, we're going to send it the position we just calculated. Now, that's going to return a value. And IntelliSense failed again. Actually, I probably failed it. Probably did what I told it to do.
I wasn't going to say that, but...
Well, I knew you were going there. I was just saving you the trouble. What we're going to do is we're going to do a check. We know that check camera points is going to return a value of -1 if it has found no collisions whatsoever. But if it's found something, we're going to get a value, and that value will be something other than 1. So we want to check to see if that value is 1. So we'll hit if nearest distance is equal to -1. That means no collisions were detected. But we also want to do an additional check called if nearest distance is greater than pre-occluded distance. What that's going to do for us is basically it says, all right, check and see if there was any collisions. Okay, great, there was no collisions. Go ahead and do this. But if there was a collision, we're going to get that distance back. We're going to check that distance against our pre-occluded distance. Because these are lines that are being cast all the way out to a position, it is possible that we hit something that is further away than our pre-occluded distance. If that's the case, then it's still safe to move our camera back out to that point.
Right.
So we'll move our camera back.
Well, technically move it toward that point. If something else gets in the way, then we're going to stop and occlude again. But
True.
that's just native to the behavior. Which, I mean, and the example would be like if we were outside and really far away from the character, and then the character goes into a little cave. The camera's going to zoom right back up because we're now in a tighter space. But then if that cave opens up to a larger location, we're going to be able to pull back, but maybe not all the way to where we were. And because of that, the code you're setting up now facilitates that, but it's not like it overrides the occlusion behavior we've already established. So we'll only push back as far as we can.
And to actually get us to push back, we set desired distance equals our pre-occluded distance. That will do the or set our desired distance, which is going to start the whole process of our camera moving back out again.
That'll start smoothing our camera back to its new location if it can. If for some reason along the way it bumps into something else, then same as before, it'll just re-occlude and there'll be a separation between the pre-occluded distance and the desired distance.
Right. And I've built this out. We've gotten no compiler errors, so everything seems to be okay here. That's going to be it for this video, but when we come back, we're going to jump back into Unity and we're going to test all this and make sure it works.
Right. So that'll wrap things up for this video. Thanks for watching.